Okay, this is the Math 1111 Zoom session for 9 p.m. Thursday, October 1st. We'll go over a few problems from section 2.8. But first, test 2 is tomorrow. And it covers 2.1, 2.2, 2.3, 2.4, 2.6, 2.7, and 2.8. See your email for instructions. And I will be sending you out tomorrow a sheet, blank copy with problems all worked out, some correct, some incorrect. The actual test on D2L will look like a Google form, and you will enter true or false answers there for the test. D2L should give you your grade immediately when you submit the test. Just remember that when you log on to D2L to take the test, from the time you log on to the time you log off, your computer will be locked down because this is the proctored test and we are using Respondus Monitor. All right, we'll just go through a few problems here from section 2.8. We'll start with, say, number 8. Here's a graph of a function. Determine whether it's 1-to-1. So it's very first section here, number 8. I made my best copy of it right here. And f of x on this one is indeed 1-to-1 because it passes a horizontal line test. Horizontal line only intersects a graph. Remember, determine for inverse. This is the input. This is the output. So pick any single input and there's only one output. You can contrast this with, say, number 10, which comes up. Straight line and over, and f of x here is not 1-to-1. Fails. We have a participant. We have been joined by someone. Let me finish this horizontal line test. That was problem 10 on page 262. I was just working a few problems from 2.8, but since we've been joined by somebody, I don't have your name. Would you like to identify yourself?
Hi, my name is Olamide Latinwa.
Okay. Did you have any questions tonight?
Oh, yes, I have a lot of questions, actually.
All right.
I printed out the review, and some of the questions I thought I did right, but then the answer was kind of confusing. Let me see. Yes, number 13 on the review.
Okay.
It says given f of x, and then it has like a graph. And then it says to find the x values where f of x is less than 2. So I got -3 and then comma +1, both in parentheses. But I think on the answer key, you got -1 and +1. But I'm not sure how you got that.
You know something? I might have messed that up. I think I have. I think you might be right. Let me look.
Okay.
Yeah. All right. So I started from -3 and I went up to 3. And then I went down to 2.
Mm-hmm.
All right. So I want to find x values where the f of x is less than 2. All right. Chapter 1, less than 2. Here's 2. That means y is less than 2, which means your y's are below 2.
Oh, okay.
So yeah, I think you're right. Yeah, I messed it up. I did it above 2. Golly. Wasn't thinking right.
So
But yeah, you're
it
below.
is
Yeah, you're below
okay.
2, starting at -3, and you're below 2 until you hit this point right here. And so that would be from, you'd have a bracket because it's a closed circle, -3 to -1. Actually, you need a parentheses around -1 because I was intended right at -1, you're right on 2. And we said strictly less. So that's actually a parentheses. And then you come up below 2, starting, yeah, I meant that to be at 1. I think I did that on the graph. Yeah, 1 and up 2. So you'd start it up again at +1, but again, it's a parentheses, and you're going to 2. Actually, I should close. This is technical. It's technical. The bracket should be on 2 because that's a closed circle, and 1 should have a parentheses because you are strictly less than. Did you get this?
Yes.
You're correct, and I'm not.
Okay. Okay. Because I was a little confused. Okay. I have a question about number 3. B, finding the inverse, I'm completely confused. I got like a really weird fraction. I got f of, well, the inverse of x is equal to x times x minus 7 over 2, but I don't think that's what you got.
Yeah, this one's got a lot of nasty algebra in it. So you want to look at 3b.
Yes, please.
All right, so the original f of x, 2x plus 5 over x minus 7, and we want to find f inverse of x. So did we get across? There were 3 steps. You want to go y equals your 2x plus 5 over x minus 7. Step 2, you want to switch your x and y. That means x equals 2y plus 5 over y minus 7. Are we losing anybody?
No, I'm good.
Okay.
So I understand right now. Okay.
All right. So nasty algebra comes from solving for y here. All right. So I have x equals 2y plus 5 and y minus 7. I'm going to multiply, clear the fraction by y minus 7 by y minus 7. So that cancels the y minus 7. Y minus 7 times x is equal to 2y plus 5. I've cleared the fraction.
Okay.
Now I'm going to distribute the x. I'll write it xy minus 7x,
Oh, okay.
2y plus 5. Okay, so what you want to do, it's just like having numbers. Your unknown is y. And it's just like having pure numbers. You want to get your unknown all on the same side. And stuff that doesn't have a y, you want on the other side.
Okay.
So you're going minus 2y minus 2y. That would be xy minus 2y minus 7. Yeah, I'll slow it down and do it just one step at a time, is equal to 5. Then I'm going to add the 7x, add the 7x. xy minus 2y, 7x plus 5. Question about that?
No, so I'm with you right now.
So far. Okay, so I'll just point out that this is where it gets strange that you're not used to. If it was like 3x minus 2x equals 7x plus 5, say, you would combine those. Those are like terms. You'd get 1x, right?
Right.
But you can't do that here. These are completely unlike. But
Right.
the only way to get down, you want your unknown by itself, is to factor out the y.
Mm.
So you can go y, x minus 2, factor out the common factor, 7x plus 5. See,
Okay.
gives you xy minus 2y.
Yeah.
All right, it's just like solving 2x equals 4 now. Whatever multiplies your unknown, you just divide by it. And that happens to be just nx minus 2.
Mm.
X minus 2, don't technically have to put it in parentheses. Cancels here, and this is your inverse function. Y equals f inverse of x, 7x add 5 over x minus 2.
Oh, okay. And if I wanted to find D, would that be the same thing, just plugging in 4 after I found the inverse?
That's correct. Now that you've got the formula for the inverse, you would simply plug in x is 4. So f inverse
Okay.
of 4 would be 7 times 4 add 5 and 4 minus 2.
Okay.
28, 5 would be 33 over 2.
Yeah. And for C, because I know like I was getting a little confused with like the fractions for the interval notation. Wouldn't that just be x is equal to 2?
Okay, x equals 2 in the sense that you have, okay, so let me rewrite the formula. Yes, 7x plus
Okay.
5, yeah, over x minus 2, and you want domain. You have your fraction problem here.
Okay.
If you set your bottom equal to 0, yes, x equals 2, but that is the number you can't use.
Oh.
Use it. It makes you divide by 0.
Oh, okay.
7 times 2 add 5 over 2 minus 2, which is 14 plus 5 is 19 over 0. That's illegal.
Mm.
So that's the only number you can't use. If you look at your number line, then you put a 2 open circle. You don't have to test either side. Both sides work automatically because 2 is the only illegal number. Sorry, I'm making the table shape.
Oh. Okay.
So you really have 2 intervals then for your domain. You have negative infinity to 2 and use the parentheses because it's open circle, and then 2 to infinity.
And so we just ignore the numerator?
You always ignore the numerator.
Okay.
Yep. There's nothing illegal about the numerator.
Okay. I'm trying to see. What else did I have questions on? Okay. Number 10, it was like find the domain in interval notation of like a bunch of functions.
Right.
For like all the square root functions, I'm a little confused because I think square root is when we use the greater than sign.
Yes. Now you use greater than or equal if it's on top, or strictly greater than if it's on bottom.
Okay. So just greater than if it's on bottom.
Right. You can't be equal on bottom.
Okay.
Yeah, the idea was I gave the same formula, pretty much x minus 4, and then put it in a whole bunch of different situations.
Yeah.
to see if you would know what to do in each situation. And if you know what to do, you know a lot of college algebra. You want to start from the beginning, or is there anyone in particular?
No, so I got A, B, and I think C. I don't know if you have the answer key with you over there, but C, I got bracket 4, comma, infinity, parentheses.
That's right.
That's right. Okay. So then D, I kind of got like a little confused.
Okay, so just to compare it with C, C has a straight square root. So yes, that puts it greater than or equal to 0. See, the equal allows you to use 4. Equals 0, that would allow x minus 4 greater than or equal to 0. X is greater than or equal to 4, which means you're allowed to use 4. That's what gives you the bracket 4 comma infinity. On your graph 4, you got a closed circle. You're allowed to use 4. But in D, I put it on the bottom. 1 over square root of x minus 4. On bottom now. That changes it to a strict greater than. Cannot use or equal.
Right.
Or equal. Because if you use or equal, that says you could use 4. Just like up here.
You can't use 4.
But you can't use 4. 4 minus 4 is 0. Square root is 0, 0. 1 over 0 is illegal.
Right.
So that's the change. So once you get to the bottom, takes off the or equal. That puts an open circle on 4, but still shading to the right.
Oh, okay.
And changes it to parentheses 4 comma infinity.
Oh, so the only difference between like it being on top and the fraction is the bracket?
That's right. See, this says you can use 4. Your square root's on top. This says you can't use 4. Square root's on bottom.
Mm. Okay, so like for E.
Okay, so you go to E and I bring in another square root.
Yeah.
I keep the first one. Then I add a square root of 10 minus x. So the idea is to handle these together handle them individually and then put them together.
Okay.
So this one works exactly like C.
Right. So it's just x equals 4?
Well, the x equals, you're putting both of them greater than or equal to 0.
Yes.
So yeah, x is greater than or equal to 4. So you'd have a closed circle at 4, shaded this way, and you get your bracket 4 comma infinity, just like C.
Okay.
But now you're adding on this. Well, if 10 minus x is greater than or equal to 0, 10 is greater than or equal to x. Because you're adding x to both sides.
Oh, okay.
Then when you switch, usually with inequality, we like our x on the left. That means x is less than or equal to 10.
Okay.
So that will put a closed circle at 10, but shade to its left.
So then it'd be negative infinity,
comma 10 with a bracket there.
Yeah.
Yeah.
Okay.
So
and so would I put like a U?
Go ahead. Go ahead.
Oh, okay, sorry. You were kind of breaking up over there. I was saying, would I put like a U, like the little symbol that says that there's two, if not this and that or something like that?
It's not a U between this and this.
Oh, okay.
See, put this on the number line together. All right, you're going to start with this at 4, close circle. And then you're going to go to its right. But you see, then you're going to get 10. See, you're not allowed to use anything bigger than 10 or anything less than 4. So then you're going to hit 10, close circle. So my domain is going to run between 4 and 10, 4 comma 10 with brackets.
Okay.
You can kind of see it by plugging numbers in. This says I can't use anything like 3. See, a 3, even though it works here,
Right.
3 is 7, but over here, 3 minus 4 is a -1, square root's an I, that's illegal. So I can't use like 3 or 2
Right.
over here to anything like that. And I can't use 11, 12, anything like that. It works here. 11 minus 4 is positive, 12 minus 4 is positive, but over here, 10 minus 11 is negative.
Right.
So you
Okay.
can only use numbers that work in both, and they're only numbers that lie between 4 and 10.
Okay. Okay, I understand that. Okay. So I just have a question about so like for G, I would just find the, what is that called? Like factor it.
Right?
Okay. And then for F, since it's being squared, can I take out the X?
No.
Oh,
You cannot. I don't know if you mean something like this. Square root of x squared minus 4, getting like what, x minus 2?
no, getting X square root of X minus 4.
Oh, an x squared like this?
No.
No.
No, like take out an X, so it'd like be X square root of X minus
X
4.
minus,
But I don't know if
no,
that makes sense.
like this.
Right.
Okay, multiply this back and see what's wrong with it. The x squared works.
Oh, but the 4X doesn't.
Yeah.
Okay.
So this does not have a common factor you can factor out. But what
Right. Okay.
you can do, I don't know if you remember this pattern. We don't go over the factoring patterns. You can, that's called a difference of squares. And you can write the two pieces, and basically you're adding and subtracting the square roots. Does this ring a bell?
Yes.
This is what you can do. You can foil this back almost in your head and see it works. The x squared, and you're getting a negative 2x, then a positive 2x. See, that cancels. I'll write it down. X squared, a negative 2x. That's round 1. Round 2 is a positive 2x minus 4. Your 2x's cancel, and there you are, x squared minus 4.
Okay.
So you can, the original looked like this, non-factored. So you then have to write it like this. You want to see it finished?
Yes, please.
All right. So it's a square root on top. That means greater than or equal to 0.
Okay.
So we've got to solve x plus 2.
Wait, actually for that one, I think it's on the bottom.
Oh, you're absolutely right. My apologies. Thank you for rescuing me. Yeah, so that takes off the or equal to. So we've got
Okay.
to solve this strictly greater than 0. All right, so that means we're going to have to write down our -2 and our +2. I'll put them on a number line with open circles because they don't work. There's no or equal to. And we've got a test between them. This one's probably the hardest one on the whole page. You got to test between these to figure out which interval gives you a positive, a strict positive.
Right. Okay.
So if I use -3 as a test, then I'm getting -3 add 2, -3 minus 2. We did this in chapter 1, but it's been a while. And you see you get a negative out of this, a negative out of this, but a negative times a negative is
It's
a
a
positive.
positive. Right.
So this works.
This works.
Well, that gives you your first interval, -infinity to -2.
Okay.
All right, so then there's 2 more intervals to test. I guess we'll pick 0 here.
Yes. 0.
Gives you 0 plus 2, 0 minus 2. You'll be able to see that doesn't work. This is positive, this is negative. Positive times a negative is a negative. Negatives are not greater than 0. That too fast?
No, I'm right there with you.
All right, good. So that does not work. So I guess we'll try, say, 3.
Okay. 3.
3 plus 2, 3 minus 2. Yeah, 3 plus 2 is positive. 3 minus 2 is positive. Greater than 0, yes.
Okay.
So then you can copy your interval notation off of this for your domain.
So it would be -infinity, comma, -2 with the u, then
Parentheses,
2, comma, positive infinity?
I'm on infinity with parentheses there. Yes, on the 2's.
Okay. Parentheses. Okay. Okay. Let's see. Is that all my questions? Okay, on number 15, um, number 15B, when it says find the domain, I know how to find it, but when I'm plugging in the numbers, would I plug it back into the top as well?
On 15?
Yes, on 15B, where it's a domain of f over g times x, and
Okay,
it was like 3x squared.
that's not f over g times x. That's a new function, f over g. This is 15b. This is f over g. This read f over g, or f divided by g. Maybe we'll call f divide
Okay.
by g of x.
Oh, okay.
So it just simply means take f of x and divide it by g of x.
Okay.
So this actually is part A. When you actually write this down, the f is 3x squared minus 4x add 6. The g is square root of x minus 4.
Right. And then I did what you said because the bottom is only greater than, so the greater than 0, and I got x is greater than 4.
Yeah.
And so with the domain, since I'm trying to find the points,
All you got to do is,
on the line.
yeah, you'd go 4, open circle, greater than is this direction. There's no numbers to plug in. Okay, yeah.
Oh. But, oh, so it's just 4 and positive infinity?
Correct. With parentheses.
Yeah, with parentheses. Okay. So when it's just like a single number, then it's just that number with whatever direction it's going in?
If you're talking about this being the single number, yes.
Yeah, because okay, yes, I see it. 'Cause I'm trying to go back to like the one that we were working on. Okay, I see what you're saying. Okay.
On that other one, you had two numbers under that root, x plus 2, x minus 2.
Yeah.
Okay. So that you
Okay.
almost have to write down. You can almost test this in your head. You really don't have to test it. That basically is saying anything bigger than 4 works. You can see that 5 works, 6 works. You subtract 4,
Mhm.
you're going to get positives. Come over to 3. 3 minus 4 is a negative. It's not going to work. So you really don't have
Okay.
to go on a test. You almost test it in your head.
Mm. I see what you're saying. Okay.
But that's a lot harder to do with two factors like this. You really have to write down both numbers and test the intervals in the middle
Mm-hmm.
between them.
Number 17. I think I just looked at the answer for this one because it looked a little funny. It looked like a fish,
Yeah.
but I was I was confused, like how, because I know that, okay, the y equals x, I know that that's the line in the middle. It's almost like, uh, what is it? Even, symmetric, like it goes like right across. But then how you got the other two lines, I don't understand.
Okay. These two lines?
Yes.
Okay. I think you'll find this one's the original f, which is square root of the 8 plus 5x. And this one is the x squared minus 8 divided by 5. So I literally entered them on the calculator and drew this graph. Do you want to see it done?
Oh, so you got it from 16A, because I thought that there were different questions.
No,
Okay.
yeah, I probably should have said refer to 16, but I'm using F from 16 and F
Oh, okay.
is from 16, yeah.
F is square root of A plus. So you just plugged it into the calculator?
That's correct. Plug both of those in the calculator.
Okay. Okay. And I can do that. I got this.
We have another participant, but I can't see names on my screen. So if our other participant would like to chime in or has a question as well. Does our other participant want to speak?
I don't have any questions right now.
Okay. Well, when you do, feel free to chime in.
Okay, thank you.
Huh? Good. Go ahead.
Yeah, I think that's all my questions. Yeah. Everything else is complete. It was just those that I was a little
Okay.
funky on. Oh, actually, number 3, real quick. Number 3A, it's still the same thing about like the interval notation, because f of x is equal to 2x plus 5 over the x minus 7.
Minus 7.
Yeah. So why is it equal to 0 and why is it not greater than?
It's not greater than because there's no square root. This is
Oh, okay.
this is a straight fraction problem. So
Okay.
with no square root, you're just trying to identify the x here. You almost do it in your head and see it's 7. But it comes from setting them to 0 and adding the 7 over and getting x is 7. See, and that's the number you can't use. Because if you put 7 in here, 7 minus 7 is 0. So I'm kind of frozen. Yeah, the internet's, okay. So yeah, that's why I've drawn the number line, put a 7 with an open circle. But you don't have to test. You only really have to test intervals if you got like a quadratic in x squared and you're got a square root, because you got to make
Okay.
that 0. So any number either side of 7 is going to work.
Sorry, you were kind of breaking up. I really didn't hear. So I get that you can use like any number before or after, but why can't we use 7? Because if 7 minus 7 is 0, isn't that what we're trying to get right now?
But it's on bottom. That's
Oh, I see what you're saying. Okay.
2 times 7. I'll plug it in on top. You can plug it in on top. That's perfectly legal. But the bottom is 7 minus 7. So you're going to get 19 over 0.
Which is illegal. Got it.
So that means you cannot put x equals 7 into this function. It's not in the domain. But every other x is. And so that is the correct way to write the domain. All the numbers left side of 7 and all the numbers right side of 7.
Okay.
If you look at B and C, we had you find F inverse. We showed you that. And you see now your problem number is 2. And so that's why the domain changes to negative infinity to 2, union 2 to infinity. Because you can't stick 2 into the inverse.
Right. Okay. Yeah, I think that is all my questions. Yeah. Thank you.
Well, sure thing. Does our other participant have any questions?
No, I was just gonna hop on and see if there was any more test review stuff you were gonna go over. But I'm okay.
Okay. Have you had a chance to read the instructions for the test tomorrow?
Yes, the Google form sheet is gonna be proctored, right? And then, but you want us to do, like, open the test on our own and figure it out and then open the test?
That's right. Now, it's not a Google form. In
Oh,
D2,
okay.
I can't use a Google form in D2L. I think it considers it cheating because it goes outside D2L. See, the point is to stay inside D2L.
Okay. I gotcha.
And that's why I can't have the questions on the test. That's why I'm going to give them out to you separately,
Oh, okay.
because I can't give you the test form inside D2L. I can only give you one form. So the form I give you, you'll have the problems worked out. Some will be correct, some will be incorrect. They're numbered 1 to 15. So when you get into D2L, they're all worded just like the Google form, though it's my best approximation to the Google form. True or false, the problem is correct.
Okay, yeah, I understand.
Okay, so if you work your problems out in advance and kind of work out what's true, what's false, and get your responses ready, then get into D2L and enter your responses, you'll minimize your time at D2L, because when you start the test to when you submit it, you're supposed to be locked down. You can't use your computer for anything else. That's why they call it lockdown monitor. Or respondus monitor. It calls using the lockdown monitor. This is the only time we're going to do that this semester. I'm fulfilling a school requirement that 30% of our activities have to be proctored. This is the method
All
of.
right.
Any other questions about that?
No, I think I understand.
Yeah, I understand too.
I'll have the test available tomorrow morning. Again, you have an entire window between then and Sunday night to submit it. Is there any? All right. Is there anything else?
No, I don't think so. Not from my end.
Me either.
Okay. Well, I appreciate y'all coming out late on a Thursday night here.
Thank you.
Your thing. I guess if there's nothing else, we'll go ahead and end the meeting.
Thank you so much for your help.
Good thing. Absolutely. Glad to do it. Thank you.
Thank you.
Thank you.